Awesome. And power sets are weird indeed. Notice I should say all of this we just talked about here, all of this is for finite underlying sets. Because clearly, like the power set of the natural numbers, for example, will be infinite. Or the power set for the real numbers will also be infinite. But interestingly enough, the power set of the natural numbers and the real numbers, because they're just things, we could have the set of them. What's this going to be? Oh, this is going to be the empty set, the set of the natural numbers, the set of the natural numbers, the set of the real numbers, and the set of the natural numbers and the set of the real numbers. So it's like the levels here are important. It's like having an array inside an array almost, where it's like it's just treated as an element of the array. But anyway, yeah, so these are clearly going to be infinite, and we'll talk about those later. Anyway, though, interestingly enough, let's talk about one thing real quick about power sets. Let's say we have the set, let's say we have pi e 5, the matrix 1, 0, 0, 1, like that. And we also have, this is A. We also have B is going to equal just E and 5. The question is, what's the relationship between P of A and P of B? Notice here that B is a subset of A. And notice that any subset of B will be a subset of A. Any subset of B will be a subset of A as well, right? Like the subset of just E will show up in the power set here. The subset of just 5, that'll be a show up in the power set here. The subset of E and 5, that'll be in the power set here. So the answer is P of B will be in P of A. So I guess that math fact is that A inside B implies that P of A is inside P of B. But we can ask a million questions similar to this. Like one question we could ask is, if will the power set of A intersect B equal the power set of A intersect the power set of b? What do you think? Well, remember, to prove this true, if this is true, that would mean the power set of A intersect B will be a subset of this. So this, like this side will contain this side, and this side will contain this side, with a double containment. Let's kind of like start the proof and see how that would go. Let's say, so here, we want to show that PA intersect B is a subset of PA intersect P of B. And so we'll use the element method. So I'll say, let C be any element of PA intersect B. Well, if you're an element of PA intersect B, the power set of A intersect B, that if you're an element of that, that means you're a subset of A intersect B, right? Power set of A intersect B is literally just the subset of A intersect B. So I'll say, thus, by definition of power set, C is a subset of A intersect B. Now here's the question. If C is a subset of A intersect B, what's that mean? That means thus, for all X and C, X is an A intersect B. Right? That's literally what it means for C to be a subset of A intersect B. It means that every element in C is in A intersect B. Why is that important? We're trying to show that C is going to be a subset of A and C is going to be a subset of B. Because if we show that, then C is going to be in the power set of both. But if we start, but it's kind of hard to see, wait, if C is a subset of A intersect B, does that mean C has to be a subset of A? Well, yeah, kind of, right? I mean, if C is a subset of A, if here's your A and here's your B, and C is a subset of A intersect B, that means C is in here somewhere. Well, if C is in here, well, clearly you're a subset of A and you're a subset of B. But the way you can show that is you say, for all X and C, X and A intersect B. Thus, for all X and C, X and A and X and B. Hence, for all X and C, X and A, that means that C is a subset of A and C is a subset of B. Thus, by definition of power set P of C, I'm sorry, no. Definition of power set C is an element of, so is in P of A, and C is in P of B. Therefore, C is in the power set of A, intersect the power set of B. Notice the difference between this in symbol and the subset symbol here, right? The subset symbol means C is a subset of A. This symbol means C is in A, because the power set of A, right, the power set of B, these are sets of subsets. So C is literally one of those elements. Whereas A itself, C is not an element in A, but it's a set built from the elements of A, meaning it's a subset. Anyway, any questions on this? We, of course, also have this side to do, but I believe in you guys. I'll say present for you. But the point is, this is how you work with power sets and things like that. Like, there's things you can do with the unions and things you can do with the complements. It gets pretty great. But there's no questions. We can finally move on to functions, which are the last thing we will cover in this class, the last thing that'll be on your exam. And so let's get after it.